Okay, and we're here with the next talk at Meeting C++ 2024. Slobodan Dmitrovic speaks about C++ for C developers, migrating from C to C++. Looking forward to your talk. Please take it away, Slobodan.
Thank you, Jens. Hello, everybody, and welcome to this talk. This talk will be a brief introduction to moving to C++ for people who have extensive C background, how we can make this transition, shall we say, smoother. We'll provide a couple of pointers, and we'll look at a couple of similarities and differences between the two languages. Okay, so let's provide an overview of this talk. We will explore similarities and differences between two languages. We will also talk about things to learn and things to unlearn when moving from C to C++. And I will do my best to provide a couple of learning guidelines so that our transition from C to C++ is as smooth as possible, shall we say. A little bit about me. My name is Slobodan Dmitrovic. I am a C++ trainer. I'm author of several books. I was research and development software developer for more than 2.5 decades. But now for the past 5 years, my time is fully dedicated to providing mostly C++ training courses to industry and academic institutions. Here is my LinkedIn profile. So I encourage you to connect with me and perhaps ask any questions you might have after this talk. Okay. So let's take a look at the C language. The C language is a standardized language. It is statically typed. It's a procedural, straightforward language, and it is used for systems programming. Now let's take a look at the C++ column. As you can see, it's quite similar to a degree. It's also a standardized language. It's governed by the various C++ standards, and there were a couple of those throughout the years. It is also statically typed, strongly typed language. But this is where it starts to, shall we say, differ or deviate from the C language, because it's a multi-paradigm language, meaning that it supports multiple programming paradigms. So you can either use it as a procedural language, or you can either use it as an object-oriented language, or perhaps some combinations of the two. And it is also a programming language used for developing systems of various kinds. So as you can see, this is where it starts to differ quite a bit from the C language, because it can be both procedural, but for the most part, it is also, most of the time, it's been used in an object-oriented scenario, shall we say. You can also program for object-oriented, you can provide object-oriented programming even with the languages that don't have classes, but it certainly helps if we do have classes, as is the case with C++. Now let's explore a couple of similarities and differences between the two. So what are the similarities? Built-in types such as int, double, float, unsigned, etc., are pretty much the same in C and C++. So all the language built-in types you have in C, you also have them in C++. So those are kind of similarities between the two. Most of them, not all, but most of them. And we declare and define names pretty much in a very, very similar way as we do in C. There are differences, but there are certainly, you declare your variables, your functions, pretty much the same way as in C. Expressions are pretty much the same. Built-in statements such as loops are pretty much the same. And functions are same to a degree, shall we say, to a degree. And we also use header and source files both in C and C++. So there are many other similarities between the two. And now let's take a look at the differences column, shall we? one of the one of the differences, not the biggest, but one of the differences is that C++ has something called reference types. And C++ also has function overloads. We can mimic function overloads in C to a degree using macros, but C++ indeed has built into the language the ability to create actual function overloads. And one of the arguably biggest differences between the two is the existence of C++ classes in C++. So classes and also templates. There are differences, vast differences between the two standard libraries. And you should also know that everything from the C standard library is also imported in the C++ standard library. Now, there are many, many other differences, but arguably these two are the biggest ones. So you should, when coming to the C++, coming with the C background to the C++ world, you should look at these two as biggest differences between the two. Okay, so when it comes to C++ classes, what should we learn in the beginning? We should learn about members, access specifiers, special member functions, objects of classes, and inheritance. So that should be your starting point when you are learning about C++ classes. Now, there are many, many more things we should learn about C++ classes, especially coming with a language that is procedural, that doesn't have classes. But for all practical purposes, these bullet points should be your starting point. And in C++, whether you write class or struct doesn't matter, because structures are classes in C++. The only difference being that default visibility for a class is private, and the default visibility for a struct is public. Other than that, they are both classes. So let's take a look at all of these bullet points into greater details. What are members? So unlike C structures, which are records for the most part, C++ classes have members. Those can be data members, represented here by variables, and member functions, represented by a couple of generic functions where I use some generic names for the sake of simplicity. So just so that you know, a class is a complex type in C++ that has data and functionality on that data wrapped into one complex type, one user-defined type. So that's how we should. So this is arguably the biggest difference, the biggest leap when we are, if we are making, but we shouldn't be making comparisons with C structs and C++ classes. So classes in C++ can hold data members, and they can hold, among other things, data members and member functions, which are the most important members of a class. Then you should be aware of the fact that code inside a class, especially with C++, can be segmented into three different levels of visibility from the standpoint of three different actors, shall we say. So we do this to limit certain actors from accessing certain portions of our class code. And those actors themselves are the class itself, the derived class, and an object of a class. So that's why we have these three different levels of visibility. Also, you should learn about some special member functions, such as constructors and destructors, and also some of the overloaded operators for objects of classes, such as the assignment operator, copy assignment, move assignment, etc., etc. So you should learn about different types of constructors, different types of overloaded operators, and there is one simple destructor in here in our case, and that should be your starting point when learning about classes. How about objects? Let's take a look at objects. So we manipulate the functionality of a class through an object of a class. We create instances of a class, and then usually through means of accessing member functions through an object, we manipulate usually data members indirectly, not directly, but indirectly. This can vary from case to case, but you should get comfortable with using objects of classes to manipulate the underlying functionality of your particular class. And finally, you should get comfortable with using inheritance in C++, where you can extend the functionality of your class in a derived class. So you can inherit from a base class. And this should also serve as a starting point for further learning. And further learning can be, for example, runtime polymorphism, designing interfaces, which is a topic of its own, etc., etc. But as you can see, I've listed 5 bullet points here, and this should be your starting ground that will enable further learning and something that will help to establish solid knowledge base when progressing onwards to other topics in C++ as well. So as you can see, it's definitely not rocket science, but they also like to say, although used in one. Now, when it comes to templates, this is a very interesting topic. What to learn in the beginning? How much of a template introduction is too much of a template introduction? There are a couple of schools of thought. One that says that you shouldn't be learning at all as a beginner in C++ about templates, which I disagree with. But I agree that you should be very gently introduced to C++ templates. Why? Because templates themselves are a universe of its own. But most of the time, you'll be just using some introductory levels of knowing about C++ templates. So what are those? So you should be aware about of basic function templates and basic class templates. And there are many plethora of other topics you should also cover, but you should in the beginning be comfortable with creating just a simple function templates and simple class templates. And this is some blueprint of how you can start with those. So just a simple starting point, a blueprint of what to expect when working with basic function templates and class templates. So once again, let's repeat this. In the beginning, only a brief introduction to templates is advised when starting with C++. Why is this helpful? Because, for example, the entire C++ standard library is implemented through templates. And it is helpful to understand, to have an understanding of some degree of template manipulation in C++ as well. As you progress on, especially if you are coming from a, shall we say, embedded background, you will certainly at some point begin to appreciate the sheer power of generic programming and templates themselves, which are widely used, especially in shall we say, embedded environments, etc., etc. Also in everyday software application programming as well. On the topic of the standard library, what to learn in the beginning? What should be our, how should we say, our starting point? Well, in the beginning, you should learn about the most widely used containers. You should learn about iterators and widely used algorithms or functions in the C++ standard library. Now, standard library itself is also very complex, very powerful library. And you don't have to learn about it, about everything there. No, definitely not. But these bullet points should help us to start progressing further with our learning of C++. So you should have this general idea that there is every C++ compiler is accompanied with the C++ standard library, similar somewhat to C standard library, as every C compiler is accompanied with the C standard library. And we include appropriate headers and use these containers and algorithms. So something that sets, shall we say, C++ apart from C is the existence exactly of these templates, especially class templates, which gives rise to immensely powerful family of containers that can store data, that we use to store data. So there are many containers there. But here I have listed some of the most widely used. So you should learn about vector, about std array, std list perhaps, and also std set and std map. So those are the most widely used containers in C++. So in C++, we don't have to create a linked list. We don't have to create a binary tree, shall we say. Not always. Sometimes we indeed do if the scenario of our use case requires us to, but we have those containers already available to us, ready-made, so we only use them. And here I've listed a couple of header files that are storing definitions of these containers, and then we simply learn to use some of these containers. So std array is very interesting to us, especially when coming from the C background. You should also learn about internal mechanics of the containers, that they have iterators which allow us to, iterators which are pointer like entities that are pointing at certain elements inside a vector. So there are some built-in iterators. We can create our own iterators, etc., etc. But basically, they are used to iterate over elements of a particular container. Okay. Also, widely used algorithms. It is up to us to decide what those are. So I can list some of them. For example, std find, std sort. So we don't have to manually sort our data. We already have this readily available for us in C++. Okay. Now back to the question of function parameters. So let's see what widely used algorithms we can use here. So for example, std find, std sort, std count, replace, reverse, etc., etc. So how should you approach thinking about these containers? Any useful operation, if you can think about on elements of a certain container, is probably already implemented in the C++ standard library. So it just becomes a matter of finding that particular function, that particular algorithm. And you then just simply use it over elements of a certain container. Immensely powerful feature. I can't recommend it enough, shall we say. Okay. Now, shall we go back to the topic of functions? Now, we said earlier that functions are quite similar in C and C++, but in C, we are used to passing elements either by value or either by pointer. And we can also pass by value. I mean, we can also pass also by pointer in C++, but this is an example where we pass by value in both languages. And that's fine. For built-in types, we indeed pass by value, by copy. But this is where C++ starts to differ from its C part. So this is why you should learn about, shall we say, references. And more importantly, by const references. So when you are passing an argument by a reference, you're not making a copy, you're actually working with the actual argument that's passed in to a function. So no copies are made. But this second example, we don't want to pass like this. Most of the time, we want to pass either by value or either by const reference for complex types. So if you're passing a complex type to a function inside C++, you are well advised to pass it by const reference, which does two things. It avoids creating expensive copies for complex objects, objects of complex classes, and std string is a class. And it also marks it as a const, which means read-only, which prevents us from accidentally changing the value of this particular argument. So those are the differences. And also, we tend not to have out variables that stem from functions. We kind of like our variables to get the value of the function, which is a scenario that is not quite widely used in some situations in C. So in C, if we want to change the value, we by address, by a pointer, and then we manipulated the pointer to value. But in C++, we like to pass by value for built-in types, by const reference for complex types, and we mainly like to assign like our function to return a particular value. We don't really deal too much with the out parameters. Also, depending on the situation, it can vary. But we can, if there is a need to consume, shall we say, operating system function, then you can certainly pass it by a pointer if there is a need to do so. Okay. Please bear with me, there are a couple more slides. So in C++, there is additional way of organizing our code. We also have namespaces, which are basically named regions of code, named scope. So a namespace is a scope with a name used to logically group a certain portion of a code. This is the blueprint for a namespace, and inside a namespace, we can declare any names we wish. So you should over time get into a good habit also of organizing your C++ code into different, shall we say, namespaces, maybe even a nested namespaces depending on the need. Okay. And another thing I should mention is function overloading. So this is where C++ really starts to differentiate itself from shall we say, capabilities of C functions. Now in C++, we can have multiple functions with the same name, but with either different number of arguments or different types of arguments. And this is called function overloading. And it's quite widely used, both for freestanding functions as in here and member functions inside a class. This allows us to implement completely different behavior of a function, and depending on the arguments applied, the appropriate overload will be called. In this case, we are calling this overload, and in this case, we are calling the second overload. So it's a very, very powerful feature. Okay, shall we talk a bit about the topic of pointers, which is always interesting. Now we're used to malloc, calloc, and realloc in C language, and for the most part, you won't be using them in C++. So, but there are alternatives there. So you won't be using them because they don't call the underlying pointed to objects constructor. They don't, once we delete them, they don't call the destructor. So you won't be using them unless you are working with some kind of allocators. So in C++, you should prefer using smart pointers to raw pointers, because smart pointers are less prone to make memory leaks, to cause memory leaks. And this is the C++ version of the raw pointer. This is the most direct equivalent to malloc, but not quite. But even this you should stay away from in C++. So that's the recommendation, at least nowadays, especially with modern C++. But I feel you need to know about raw pointers in C++, if only to discourage their use in favor of smart pointers. And by smart, 90% of the time we mean unique pointer. And this is the version of the unique pointer. Don't be scared about the verbosity of naming conventions of smart pointers. Over time, it will become your second nature. Notice the absence of any need for delete UP here, because when this unique pointer goes out of scope, it will, through its destructor, automatically deallocate memory and destroy the object by calling the pointed to objects destructor automatically. So this is the way we should approach dynamic memory allocations in modern C++. And when they go out of scope, they clean up after themselves, and that is why we prefer using unique pointer nowadays, especially in C++. But I feel if you are coming from a C background, you should take a couple of steps prior to progressing to stud unique pointer. So you should get familiar, if only with this particular use of raw pointers. So this is a raw pointer version, and this is a, shall we say, smart pointer version. There we go. Okay, so that's one thing. No malloc for the most part, no realloc, no calloc. Unless you are developing some allocators, but that's entirely another story. But for the most part, you should leave those to C. Okay. Now, one of the pain points are actually raw arrays and raw pointers. So let's take a look at the raw arrays. We are used to working with the raw arrays in C, and that's perfectly fine when programming in C. And we are used to working with raw pointers when programming in C, and that's also perfectly fine. Most of our operating systems ultimately are developed in C, but there is an underlying potential for problems when using raw arrays and raw pointers, because either memory leak can occur, or we can or an array decays to a pointer. So that's a nasty, potentially nasty problem. So instead of raw arrays that are used and also present in C++, you should prefer the use of stud array, which was meant as a thin wrapper around the raw array, around C array. So this one doesn't get converted to a pointer when used as a function argument, for example, whereas this one, we like to say that at slightest provocation, arrays get converted to pointers. I think Bjarne said that in the book. Okay, so this is the one we want. This is the good stuff. Also, alternatively, if you are not worried about underlying vectors mechanics, and vector does allocate memory under the hood, so you should be aware of that, you can opt for a vector. So any dynamically resizable array presentation can be ultimately utilized through a vector. So you can think of a vector as a dynamically resizable array in C++. Also, you should be aware that C++ standard library is a reliable way of storing data. It has stood the test of time quite well and is used also in mission critical scenarios as well. One thing you should be aware of, that you shouldn't inherit from standard library containers. So that's out of the question, but for all other use cases, you should refer to standard library containers, or you can create your own container if you wish, using classes and templates. Okay, so with that out of the way, shall we take a look at a couple of frequently asked questions I encounter in training, especially from people who are coming from a C background, and my answers to them. So is there such a thing as a C/C++ language? Now, C++ developers are very categorical about this. They like to say, no, C and C++ are two different languages with two different paradigms. And I agree with that view. So mixing the two styles is probably best avoided. So when you are writing a C program, you should think in terms of a C language. When you are writing a C++ program, you should think in terms of C++ language. So mixing the two styles is discouraged, shall we say. Now, is C++ actually C with classes? And we also like to say no, because C++ started off as C with classes way back in the days, but has since evolved into a completely different language. So no, C++ is not C with classes, it is C++. Often people with the extensive C background, when they are encountered with the references, ask me, are references pointers? And I like to tell them, no, they are not pointers. References are not pointers. References are different kinds of types specific to C++ language. So we should treat them as that. They are types whose variables are basically aliases for something that is already there in memory. So it's just an alias for something that is there in memory. And we also use the references to extend the lifetime of temporary objects, etc., etc. The story goes on. And then when I say that references are not pointers, they like to ask me, are references implemented as pointers? And I should give an answer that we don't know and we don't care, probably, possibly. And actually, we don't know and we don't care, as that is an implementation detail, and the C++ language doesn't specify too much about how references are implemented. Chances are they're implemented as pointers, but the very important thing is that you shouldn't think of them as pointers. They are simply references. That's how we think of them, and that's how we treat them. Mainly used as a type for a function parameter so that we avoid creating temporary copies of function arguments. That's how we treat references for the most part. Okay. One of the questions is the C++ standard library is quite involved, quite large. How can I learn everything about it? And the answer is you don't have to learn everything about the C++ standard library. You only have to learn about the parts you'll be using or are mainly used. So we cover those. Couple of widely used containers, couple of widely used algorithms. If you want concurrency through multi-threading, we also have wrappers for that. If you want other facilities, they are still available to us. But basically, you only learn what you'll be using, what you need to use. How about structs? Can I use them in C++? Yes, you can, but structures are classes in C++, so we should learn about C++ classes in general. There is also a notion of the plain old data revolving around structs in C++, but that is a topic for another discussion. So you treat structures as classes in C++. Whether you write struct or class doesn't matter, as long as you have this notion that the default visibility is the only difference between the two. Should I learn everything about templates? No, definitely not. Only a brief introduction to templates is advised in the beginning, especially when coming from a C background or maybe some other backgrounds. Doesn't matter really. How about error handling? Well, in C language, we are used to working with functions returning error codes. And then we inspect in some table what the actual error code means, what it signifies. But in C++, we can resort to using exceptions, handling exceptions through try and catch blocks, shall we say. So we should prefer handling exceptions rather than returning error codes from functions. And as we are nearing the last slide, let's take a look at things to unlearn and things to learn. So if you're coming from a C background, I know that old habits die hard, but you should make an effort if you're programming in C++ to unlearn the following things. The use of row arrays in C++. We really tend to stay as much as possible from these, and especially from raw pointers. We tend to stay from raw pointers as much as possible. It is not always possible. There is a lot of legacy code left, but the general consensus is that we should part from raw arrays and raw pointers because they can cause problems down the line. Unless used in a very careful manner, but that's a different discussion. Also, this is very important. You should part away with using character arrays to manipulate strings. It's perfectly fine in C, perfectly fine, probably the only way. So don't use character arrays to manipulate strings in C++. And don't use pointers to string literals to represent strings in C++ as well. Not always possible, but you should strive towards using different facilities, and we'll see which those are in a moment. Also, when we are programming in C, we like to think in terms of bits and bytes, do a lot of pointer arithmetics, and that's perfectly fine for a C scenario. But in C++, we tend to delegate this task to standard library facilities and let them do all the heavy lifting. So we tend to stay away from these things, and we are not thinking of in terms of bits and bytes, but rather in terms of objects. So what would be the opposite things as compared to these bullet points? What would be things to learn? You should get comfortable with using containers and algorithms from the standard library as compared to using raw arrays and raw pointers. So use std array, perhaps std vector or other facilities, but definitely try to depart from raw arrays and raw pointers as much as possible. Not always possible, but we should strive towards. It's not always possible, especially in embedded environments, and some even if you are working with operating system, shall we say, functions that expose raw pointers, then we don't really have much choice, but we can also use this function to, if they are using pointers to output data, we can use them in a scenario where we output data to a vector, for example, instead to a raw array of some kind. And we should learn to use smart pointers as much as possible, especially 90% of the time, unique pointer, which was meant as a replacement for a raw pointer. And also we should learn to use std_string type to represent and manipulate strings. So all the heavy lifting as compared to C string manipulation is delegated to this std_string type, which is underneath, it's a complex class, and it has a plethora of useful things that allows us to manipulate strings, create substrings, concatenate strings, etc., etc. So we should use std_string to represent. It's the idiomatic way of representing strings in C++. And also, finally, we should be using, if our task requires of us, to use classes and templates. And one final bullet point for this slide is that we should start thinking in terms of objects and not of bits and bytes. So objects we can visualize them as rectangular areas having a type, having an address, potentially a value and a name, and that's how we think about data in C++, or at least we should strive towards thinking that way. Okay, so with that in mind, I'd like to thank you for listening this talk. I hope you find it useful, and I'm looking forward very much to your questions after this session. So thank you once again.